Good morning, everyone, and welcome to a particularly useful topic, especially geometric series. We're going to see so many financial applications of this idea, but arithmetic and geometric series. All right, what are arithmetic and geometric series? Well, we already looked at the example of Gauss, who was asked to add together the numbers 1 through 100 and was able to do that very quickly by computing that as an arithmetic series. Now, he did not invent that math. Sorry, he did not invent that math as an 8-year-old. He discovered it for himself, but it was already well established. It was already studied by that time, but that was just one of the early markers of Gauss's genius. And so if you're just tuning in now for the lesson, I encourage you to look up on YouTube Gauss, Gauss, and say 1 to 100, and you'll be able to hear this story as well. So arithmetic and geometric series, what are they? Well, a sequence is what we studied yesterday. This is a progression of numbers that change by a constant difference or a constant ratio as they grow. And then a series is what happens when we add together all the terms of that sequence. Okay. Now, yesterday we were looking at sequences that didn't necessarily have an endpoint, but with series, of course, we need a definite endpoint unless they converge to zero, in which case some geometric series can be added together infinitely. We're not going to be looking at those. Okay, so the derivation, the place where we get these formulas, okay, that's a particularly beautiful part of math. It's something I really enjoy. Your textbook treats both of these two ideas of where we get these formulas. And if you're interested in taking a look at that, I'd encourage you to go ahead and examine that for yourself in the textbook, or you can look these up online. But for today, I recognize that people want to get at it and start doing some practice problems. So I'm just going to show you. Here you have the sum of myself and my son, a series of Jennings in the frame here. So in any case, this formula here, and you see these formulas, you're like, whoa, that's complex. I want to make sure I can remember that. So you're going to write it down. So I'm going to write this down here. This is for the sum of an arithmetic series. So the sum of n terms, if the sequence that this is based on progresses arithmetically, then you would use the number of terms divided by 2 multiplied by 2 times the first term plus n minus 1 multiplied by the difference. Okay, that will be this formula that you use for an arithmetic series. That's right, Mr. Man. Yeah, this is a little bit not kindergarten for you. Okay, so if we go back and take a look, let's just test our results for Gauss, okay? And what happened with Gauss? We noticed that this is the story. All right, Mr. Man, you go see your grandpa, okay? You go see your papa. There you go. Go on over. Go cuddle your papa. Okay, so if we're adding 1, 2, 3, all the way to 9,900, we saw we could turn that list on top of itself, add 1 to 100 is 101, add 2 to 99 is 101, and we would have 50 101s to add together because we would have to do that 50 times. So let's test this result using this formula here, okay? And we'll see how to use these formulas. All right, so the sum of the first 100 terms of this very simple arithmetic series, 1, 2, 3, 4, 5, all the way to 100. Okay, so the sum of this series is n over 2. So that's 100 is the number of terms divided by 2. So that will give us our 50. Okay, multiplied by 2 times the first term. The first term was 1. So we will have 2 times 1, which is 1. Which is 2. And then add together n minus 1 times d. Okay, n minus 1 times d. Well, n minus 1, this is be 99, multiplied by d, and the difference for that was 1. Okay, so there we go. Because why was the difference 1? Well, I would take 2 and subtract 1 and find that that is 1. Or I could take 3 and subtract 2 and find that the difference was 1. It grows by 1 every time, folks. Okay, so that's why 1 is there. All right, so now let's progress this to another line. S of 100 is going to be equal to 100 over 2, so that is otherwise known as 50, multiplied by 2 times 1 is 2, plus 99 times 1 is 99, and then 2 plus 99 is, there's our 101. Okay, so in fact, we get the same thing that Gauss found, but he could go directly to this step in his head probably because because it's a very simple arithmetic sequence. This will work for all arithmetic sequences, regardless of what number they start on or what their difference is in between them. Okay, so that's how you use this formula, and then we would get this. Just evaluate that. That's 5,050. There you go. Okay, so now let's come back here. All right, and we'll come back and take a look at geometric sequences in a moment. So now, let's suppose that we have this arithmetic sequence that we want to find what is the series at 16? What is the sum of the sequence of the first 16 terms? Okay, so let's use our formula. We would have S of 16 is equal to, well, I'm just going to write out the formula because it's good to write these things out, and it helps test your memory. N over 2 multiplied by 2a plus n minus 1 multiplied by d. Okay, and then I'm just going to go check and make sure that I have the formula correct, and indeed I do. So let's go for it. The n is already 16 over 2, so that's fine. That's going to be easy to work with. That is 8. And then we have 2 multiplied by the first term. So the first term there is 20. So that's 2 times 20 is 40. And then I'm going to add together n minus 1, so 16 minus 1. And if you skip a step and you write down 15, okay, that's between you and your rough work, okay? You are going to take the responsibility for your actions. And what's the common difference here? Grows by 7, grows by 7, grows by 7. I really believe that the people who preceded me in the math department at CCI love Fibonacci numbers as much as I do because they show up all over the place inside their work. Okay, so D here is 7. Okay, now end our bracket. And then do Bedmas. I can do this because even though it's outside the bracket, I can still do that now because it's not going to affect anything else. So that's 8 multiplied by the results of this bracket. 40 plus 15 times 7. So let's write that down. 40 plus 7 times 15. Okay, there we go. And 7 times 15 is 105. 105 plus 40. Pardon me. 105 plus 40 is 145. So we will have 8 times 145. Now someone should be checking my mental math. Okay, I just checked my mental math and it's correct. Okay, so that is 105 plus 40 is 45. Okay, so now let's do this. 8 times a 145 is, hey, at some point, Mr. Jennings, you got to go to a calculator, give us all a break so that we don't have to watch you do mental math. But that's very much in the realm of mental math, but this is just slightly faster. 1160. Here we go. So this answer is 1160. And I would encourage you to do as much of this by mental math as you can because it's an excellent workout. But you're not here to watch me do bicep curls, so that's why I used a calculator. Okay, let's keep going. Now, we're going to have word problems as well. And so here, it really helps to sometimes draw a diagram or a picture in these situations. So a Greek theater has 30 seats in the front row of the center section. Can you imagine one of those like theaters where the stage is actually at the bottom and all of the seats rise up around it like a fan shape? That's what they mean by Greek theater. So there's 30 seats in the front row. So you might draw 1, 2, 3, and say that's 30. And then each row behind the first row gains 2 additional seats. So then the next one would be like 1, 2, 3, 4, 5, 32. And then 1, 2, 3, 4, 5, 6, 7. That would be 34. There's that number again. I think they like that number. Okay. So how many seats are in the center section if there are 13 rows? Another Fibonacci number. It's just like they love Fibonacci's. So there's 13 rows. So this goes on to 13 terms, okay? And we want to know how many seats are in this section, okay? So let's do it. We know that the sum of this series is 13 terms, and that's going to be n divided by 2 multiplied by 2a plus n minus 1 multiplied by d. Okay, so let's sub in our numbers. We know that there's 13 rows. So if there's 13 rows, each row is a term in the arithmetic sequence. So to find the series, I need to know, okay, there's 13 rows. So 13 divided by 2, okay? And then I'm going to multiply that by 2a. So 2a is 30 times 2. And then I'm going to put in n minus 1, so that is 12 minus 1, okay? And then d here, d is the common difference. Okay, grows by 2, grows by 2. It was told to you there, grows by 2, okay? So d is 2, okay? And now evaluate. 13 over 2, I'm just going to leave that alone because I don't want to write an ugly decimal down. I'm just going to leave that as a fraction. That's fully reduced. So 13 over 2 multiplied by 60 plus 11 times 2. 60 plus 11 times 2. 11 times 2 is 22. 60 plus 22 is 82. Okay? Now, I'm going to cancel this, and the 82 becomes 41. Mr. Jennings, what are you doing? How did you do that magic? Well, I know that if I divide 82 by 2, I will get 41. So I'm just going to do that first, and it's going to give me the simplest thing to punch on my calculator. This is, again, something we could mental math, but I'm just going to punch it on my calculator because, again, no one wants to say, oh, today I watched my math teacher stare up to the upper right corner while he did sums in his head. 533. And some of you are like, Mr. Jennings, I did it in my head from there already like 5 minutes ago.
Why are you doing 12 minus 1?
Why am I doing 12 minus 1? That's a very good question. Who asked that question? Is that Damon?
Siraj. No, that was Siraj.
Okay, thank you. This should be 13 minus 1. The reason I'm doing 12 minus 1 is because I did it in my head, and then I wrote down the answer, and then I wrote minus 1. That's why I did that. So let's fix that. So there we will have 12 times 2, which is 24. And so this will be, instead of 82, it will be 84. And then this would be 42. And then this would be 13 times 42. So over here, I just need to add another 13 equals 546. So there we go. That's going to be the correct answer. Now, yeah, my mistake here. This 13, you want to substitute that in carefully in all the spots where you see n in the formula. That's the number of terms, so it goes there and it goes there. So when we have 13 minus 1, that's 24. 12. See how I'm just doing the work ahead, and my brain is not keeping up with my mouth today? That's what's happening. 12 times 2 is 24. 24 plus 60 gives me 84. 84 divided by 2 gives me 42. Okay, so that's how the error cascades down through my work. And that's also why I really appreciate having students here to keep me honest and to make sure that we find all these things. It takes a village to teach a class, as I was mentioning. All right. And now that's going to conclude this video. And then we will start another one for geometric series. So hit me up with questions in the chat or by email.